Hi, I'm Hunter. I made the game Hexabon United for the Game Maker's Toolkit Jam 2021. So first I'll show off some gameplay if you want to check it out. And then if you want to stick around, I will dig through some of the Unity and C Sharp implementation and show you some of the architecture decisions on how I made it, which you might find interesting. So the game's pretty simple. It's a puzzle game. It's a Hexabon style puzzle game where you have a grid and you need to get some piece to an end objective. It's on a hexagonal grid, which is the twist number one of the three twists. Twist number two is that there's no pushing blocks and then leaving them there. You are stuck to them. You are joined together, which was the theme of the jam. And then lastly, you can move more than one piece at a time. You control different pieces, just sort of react to different controls. You have movement pieces that will all, there could be more than one, that will all react to you trying to move. And you have rotation pieces, which won't move, but they will rotate all of the pieces around them, 1/6 the way around. So then you get stuck, and I can rotate this entire arrangement and get it to the end. And then, of course, multiple pieces. Like this one moves down, this one can't. Actually, just didn't lose. Oops. Oops. There you go. You can undo. Let's see. So this would be like the canonical puzzle, where there's a bomb. It's gonna blow up. It's going to just disappear because I didn't do any actual animation in this. So you need to figure out how to use both of these blocks to solve the puzzle. Cool. And then this is where the game actually gets interesting, is when the movement and rotation sort of work together and you have to like create interesting arrangements. Yeah. So what works well about it would be just a general gameplay as a puzzle mechanic. I think it's pretty nifty. Input is tough. Input is probably what works is the hardest thing, because there's no like standard. Just use WASD, for directional movement. You got 6 directions. So the solution would be like pretty good mouse movement. Putting little, you can hover over the piece, have little buttons appear, or the nearby squares get highlighted. That I think is the solution to that. Yeah. So I'll stop playing here. I'm just like solving them because I know all the solutions. So I won't spoil some of the better puzzles that are the trickier ones. So that's my game. I'm pretty happy with how the puzzle mechanics worked out, and I'm pretty, I guess you could say, unhappy with how little time I had, and I just like didn't do any sound design, didn't do a visual polish, didn't do animation, or didn't do player feedbacks. I did a help menu, but so it goes. And you can use the comma and period, the little colon bracket, the chevron bracket keys to skip levels. Okay, so that's the game. Go play it. Link in the description. But now I'm going to dig through some of the Unity and show off the code architecture and to tell you how it works. You might learn something from this if you want to make little grid-based games. Here's one way to do it, and some pros and cons about that. So the main underlying feature I am using in order to do my where's my game level? Zoom in there. To do my puzzles is the Unity's built-in tile map that comes with its 2D. If you use the 2D template, or you just go into the package manager and install the 2D tools, you can install a tile map, which allows you to draw and erase and select and flood fill and do all sorts of things with tiles. There were 2 tiles, it was 3, but I cut this mechanic because I just couldn't explain it easily. It's a good mechanic. If I finish a game, there'll be more of it. it's pretty nice being able to just use Unity's built-in tools, set up some keyboard shortcuts for brush and delete, and just draw and just paint. And you can iterate really, really fast. So to do that, what I needed to do was to create an object, a C# object that extends in default namespace, that extends tile. So I extend tile. All I've done is added this thing called floor type. Floor type is a scriptable object, but it basically didn't really need to do that. I could have put this logic in the tile. I could have put it here, but I wanted to be flexible because I didn't really know how the game was going to work when this is like some of the first code I wrote. But anyway, it contains the logic for whether or not you can walk on the tile. In my case, all of them can be walked on because visually I can just delete tiles. I don't need like wall objects. If it is a goal, yes or no, pretty simple. And that other mechanic I deleted, the tiles that can only have certain types of objects on top of them. So I have a component, a mono behavior that hangs out next to the actual tile map. And when we begin, it loops through all of the tiles in the bounds, and then checks to see if tries to get a tile. If it's not null, and if it is a hex tile, then we add it to a map. So I just loop through all of them, check them. There's no way to just do a get all tiles in the tile map, unfortunately. So this is good enough. The map is just a wrapper for a dictionary, but it provides some convenience functions. It creates the cell objects for us, the plain old C# objects that hold the data type of a cell, really just holding the position and a reference to the floor type. So that way the actual map that the game logic uses is disconnected from that tile map because it's in Unity. That tile map's kind of annoying to work with. So when the scene loads, we look at that and use that to create a map in plain old C# that we like, that is in nice, convenient objects. And the coordinate system is in cubic coordinates. So what that means is that there are 3 axes. There's the x-axis, the y-axis, and the z-axis, which is interesting because it's a 2D grid. But you can define it as x, y, and z. So then the cells are in line with each other on axis. They all share that one coordinate. So it is not the most efficient. You could do it with 2D ways, but it's a really convenient way to store the positions. It's really easy to do math on the rotations. It's really easy to do the math on like finding ring distances and pathfinding and all sorts of stuff that you might want to do with hex systems. I have a utilities class. Actually copied this code from another project that was on a hex grid where I take the positions from Unity's tile map and I convert them into hex. And then I have a similar thing for getting the world coordinates in the scene and converting that into I get the grid's cell position in the cell coordinates, and then I get the cell position. My math's a little wonky, I had to kind of fix it, it's fine. But anyway, so when the game begins, all of the different prefabs that are the different objects in the game, they will figure out what tile they are, they will figure out what cell they are on, and they will tell the cell that they are on, hello, I am here. And the cells, that plain old C# object keeps track of the whatever entity is here, which makes it really convenient whenever I'm trying to find a neighbor or find if the space is available, like if I'm trying to move there or whatever. I just keep a reference to the map, and that I can get to anything I need from there. I'm not checking it to see what the walkable space is, then checking something else to see what type of entity might exist. It's all stored in this one location. So we generate that, plain old C# objects, create them on awake. That's kind of it. The agents are what I call the things that actually do the moving. They are both components that look for the tile agent. So there is a tile agent which says, hello, I am a thing that can be on a cell. I can take up space. And it has functions that I added to look for what neighbors it has, and get a list of every single neighbor connected in a block, in a group that is connected to it. Attach itself to a cell, and so on. A little overcomplicated way to attach yourself to cells instead of just setting the cell's entity property to it. It does it through a function and does it through so it says, I have left that cell and I've arrived at this cell. And the reason I'm using those functions, those wrapper interfaces, is just so I can find the bugs. It's just so that if an agent has not left a cell when it should have, or if it belongs to multiple cells, I have a function that can figure that out. And I can do my debug.logs, and I can click through my code and I can see, okay, what's going on there. And that was some of my bugs, and that did help me find them. Yeah. So the commands, they listen for input. Something calls onto them, their movement or rotation command, and they do all the logic that makes sure only one, if it's in a block that's connected, only one of them is actually going to move the whole block. That way it doesn't move too much. And then it tries to see if they can all move, and so on and so forth. Pretty standard game logic. But what's interesting, the next interesting decision is to add undo support. I have a command system. Command system is a pretty nifty pattern. Any action in the game that can be undone, you encapsulate into a little C# object that is a command, or it extends an interface of iCommand. You don't need to call it iCommand, you can call it whatever you want. But iCommand has a execute and undo functions that the command you create needs to be able to execute and undo. And some other stuff for some other stuff, but that's the core of it. Like animate, I like to execute logic first and then have the gameplay catch up. That way I can have the animations, if you do a bunch of moves in a row, the animations can skip to the end, or if you undo while a move's still animating, it'll cancel it automatically, and some other, try to remove the logic from the animation so that you can do the things faster than the animation. I didn't even implement any of that in this game, but I knew I would, so I put it there. So when a thing is making a move, all it's doing is actually making that command. It's not executing it, doesn't do the code, doesn't move the objects. It just makes this command object, and it sends it to the input system. It sends it to the game manager, which is our undo command system. So that takes the command and adds it to a list and executes it. And then when you undo, it pops it off the top of the list and undoes it. And it doesn't matter what command it is. A bit of extra logic so I could have multiple commands stack on each other and only one of them be the actual command. There are better ways to do this, kind of a jam hack, but so the move command, when we create it, we give it a list of all of the agents and all of their destinations. We could have made that a dictionary. In fact, the first thing I do is convert it to a dictionary. I could have had the thing just give it this in the first place. Might make a bit more sense. And it also keeps the dictionary of their previous positions so that it can undo, of course. It just unsets it, puts them back. Which is neat, right? So it's able to undo the state that it changes. And then as long as you don't mess your list up, and then you always undo and redo in order, everything should be fine. So commands are, full undo support kind of baked in right out the bat. You notice I don't have a rotate command. Rotation is a move command. Since I didn't do animation, I didn't need to actually make a separate one because it just says this object is over here now. That's a move. And rotation is that. This object is over here now. I'm not actually rotating the pieces. I would need to do that if I were to, do and make it better. Right, so here's the bomb command, which says, okay, well, there are two objects that are blowing up. There's the object and the agent. The thing that can be on a cell that can be walked on top of, and the thing that can be on a cell that cannot be walked on top of as far as path finding and grouping objects is concerned. Badly named. And it just activates and deactivates them and vice versa. What other interesting things? I got a Pathfinder from a different project. Didn't even use it. Nice to have. Yeah, I guess the only other interesting pattern is the level manager and the state machine, but both of those are from another, are just these little open source projects I've made on GitHub that are that I just use for jams. That's like the point of their existence, is to like allow me to like quickly actually make the game and the game logic and not worry about menu opening and closing. But I'll talk about the state machine because that is convenient, and I won't talk about the level manager because it actually caused me a bunch of headaches. There was a bug in my level manager that on my previous projects I've used the level manager for. I didn't have a bug because there was a transition. It would unload and load everything, and then untransition, and then a manual initiation function would get called. I wasn't using the start and awake events in Unity, and there was a race condition bug. So here I like didn't bother with like transition screen wipes and manual, like, okay, now that the thing is out of the way, you can begin. And I got a bunch of issues with the scene not being unloaded when the other scene like initiated, and then agents that were in the scene that was like on the way out were still getting put in the new map. Gross. And then getting deleted immediately. So anyway, don't worry about that. But the state machine is cool. A state machine is it's a flowchart. It's a flowchart. Unity's animation system is a state machine that Unity uses. But I made one that uses scriptable objects. Scriptable objects are wonderful. I love them. It's a little convoluted to set up like in the editor. I wouldn't ever release this as an asset like on the asset store because like it's just like not easy to use, but it's still conceptually simple. It's not that bad. There is a machine that contains a bunch of states, and it can only ever be in one state at a time. If we hit play, it will tell me that I am in the gameplay state. I don't know about that. And gameplay state means that my inputs will catch and so on and so forth. But if I hit the escape key, that's actually going to transition me into a how to play state. And then now if I try to move QW, whatever, I can't because I'm not in that state. My inputs are disabled. Tap escape, my inputs are enabled, but I didn't manually do anything. All these things are just a normal input script. Just an update script, just does some input. And then another component that says, oh, let me see if the state has been activated. And let me see if the state has been deactivated. And let me activate and deactivate this object to match. And then that's how the victory appears. So to transition between the states, there are transitions, which are a list of conditions, things that are true or false, that must be met. And if all of a transition's conditions are true, then it will transition. So for example, in the how to play state, you press escape. It only has one condition, which is that I just did this event that I'm telling it to transition now, and it just immediately does it. And then for the victory state, after every move, we ask the question, how are all of our transitions doing? And then I call that triggering the machine. So our code for the stars being on the stars, that actually makes it really simple and convenient. I called that a baby. It has a Boolean called is at destination. It extends I condition, which means it has a function that returns a Boolean. That's literally all that interface is. And it tells this transition, oh, you got to pay attention to me. You got on star, you got to pay attention to me. And if I get destroyed, we actually lose this, which means you can destroy if there are 2 stars, you can delete one of them and then get the other one to this end, and that will be a valid win. None of the puzzles let you do that because that's definitely a bug. I should actually I think I should just comment that out. But anyway, so I condition the transition keeps a list of whatever's state, scriptable objects or mono behaviors or anything that extends this interface. They keep a list of it. If they've added it through a drag and drop list of scriptable objects, or I've added it through this function add condition. And then now this transition knows, okay, I will pay attention to this. And that's just because they're scriptable objects. All I have to do is make sure my prefab for the baby star goal just knows what transition is the one it needs to pay attention to. Bing, bang, boom. That sounds super complicated, but once you set all that code up, it means I can have really complicated win and lose conditions. I can have things that die and things that lasers that point at things and timers and how many turns, how many WAs, like how many turn counters could you do, all that stuff that would be like coming from a lot of different systems in the game. As long as they can all tell this state machine what conditions to pay attention to, they'll be all right. So the concern with that is scriptable objects need to get reset. So I reset it in awake, and then on start, I have to do all those, after awake, all those attaching to transitions and so on, which can be buggy because you have that raise condition. And it's basically a singleton pattern, right? They all have to know about the same machine, right? But because they're scriptable objects, I can pretty easily ignore them and reassign them and set them to be defaults and so on. So super nice. That's great. The level manager for going between scenes isn't great, and I don't love it, and I want to rewrite it from scratch. It caused me a lot of headaches on this game jam, so we're not even going to bother sharing it off. But basically, I have a list of all my scenes are in the list. Scene references aren't something that you can do in Unity. I have a little extension script that I've written. It's bad. When you drag it in there, it keeps track of the build index and the name, and then it uses one of them to actually ask for the name or the index so it can do the scene loading. So if you were to change the build index or rename the scene, you have to then re-drag and drop the scene into this slot, and it messes it up. I changed it from index to name, but I didn't change it everywhere, so now both are important. Ugh, it's a mess. So anyway, once all those systems are in place, it means I can just really quickly, I can just sit and draw and grab prefabs and just stick them wherever I want. And that just update, it just works. It just works, right? My level manager at the very least will load up my other scenes that are compartmentalized. And it's great. When it all works, it's great because quickly designing puzzles and quickly iterating is the most important thing in a game jam, is to be able to just, I put together a good amount of puzzles in a short amount of time. And I think most of them are all right. And that's thanks to getting all of this stuff in place on Friday and Saturday morning, and then having most of Sunday morning to just make all these puzzles. All of Sunday to make the puzzles. I didn't do any. I probably wrote almost no code on Sunday. When I was for me, it was due at 2 p.m. So it's not a lot of time. Are there any other interesting Unity architecture pieces that are important here? I don't think so. Cool. Okay. Anyway, hope that was helpful and educational.